some basic example of linear transformation which had come in CSR net. This topic is actually depend which topic I had discussed in my previous lecture. So at first I will highly recommend you, if you don't see my previous video of linear transformation and vector space, please see at first this video. Then today's video and my next video will be so easy. First example which had come CSR net June 2019 exam. The example is, let V be a vector space of dimension 3 over R and consider a linear transformation T from V to V given by the matrix A equal to 1 1 minus 2 minus 1 minus 4 5 0 3 minus 3 with respect to an ordered basis V1 V2 V3 of the vector space V. Then which of the following statement is true? Option 1, TV3 equal to 0. Option 2, TV1 plus V2 equal to 0. Option 3, TV1 plus V2 plus V3 equal to 0. Option 4, TV1 plus V3 equal to TV2. Let's see the option. This is just basic topic. Here notice, since T be a mapping from V to V itself, so obviously this linear transformation be an operator. Okay? And here given the ordered basis of V is V1, V2 and V3. Also ordered basis of V is V1, V2, V3. And here the actual concept is matrix representation with respect to this basis of this operator. And in the question, the matrix representation such type, and here the actual concept is matrix representation with respect to this basis of this operator. And in my earlier video I had seen TV1 would be such type, since here the basis vector V1 V2 V3 would be such type A1 V1 plus A2 V3 V2 plus A3 V3, and TV2 would be such type B1 V1 plus B2 V2 plus B3 V3, and TV3 would be such type C1 V1 plus C2 V2 plus C3 V3, and the coefficient matrix would be this scalar be as a column vector A1, A2, A3, and this scalar be also be on the column, second column vector B1, B2, B3, and this scalar be the on the third column vector C1, C2, C3. This is the coefficient matrix. By this idea, with this given matrix, then TV1 equal to, apply this idea here, then this would be V1 plus V2 minus 2V3, and TV2 would be, apply this expression here, minus V1 minus 4V2 plus 5V3, and TV3 would be 0 times V1 plus 3V2 minus 3V3. Are you getting the expression? Oh well. Now let's see the option. First option, TV3 equal to 0. TV3 equal to 0 means 3V2 minus 3V3 equal to 0. That imply 3 times V2 minus V3 equal to 0, and that imply V2 equal to V3. And since V1, V2, V3 are basis vector, so obviously V1, V2, V3 are linearly independent. But here I have got V2 equal to V3. That means they are both linearly dependent. But this is wrong. because v1, v2, v3 are bases of the vector space V. So this is cannot possible. That means option 1 is a wrong option. Are you getting? And option second indicate T of v1 plus v2 equal to 0. And then apply this part also. T of v1 plus v2 equal to 0, and since T be a linear transformation, so we can write this as T of v1 plus T of v2. And now put the value v1 plus v2 minus 2v3 minus v1 minus 4v2 plus 5v3 equal to 0. Omit this portion. Then minus 3v2 plus 3v3 equal to 0, and this is also similar to first option, that imply 3 times v3 minus v2 equal to 0, and that means v3 equal to v2. This is the same type first option. This cannot possible. So option 2 also be wrong option. Option third indicate T of v1 plus v2 plus v3 equal to 0. T of v1 plus v2 plus v3 equal to 0. That means similar to before, since this is linear transformation, then this imply T of v1 plus T of v2 plus T of v3 equal to 0. Now put the value, then this would be v1 plus v2 minus 2v3 minus v1 minus 4v2 plus 5v3 plus 3v2 minus 3v3. Now calculate this part. Obviously all part would be omit. So obviously this value would be 0, means 0 equal to 0, and this equation always possible. That means option third is a right option. Option third is a right. And fourth option indicate T of v1 plus v3 equal to T of v2. This is T of v1 plus v3 equal to T of v2. Then after by using linear transformation, now put the value. Then this would be v1 plus 4v2 equal to minus 5v3, and this value is T of v2. And notice here I have got this part not equal to this part, because this is equal to minus v1 plus 4v2 minus 5v3. Notice v1 plus 4v2 minus 5v3, here this is equal to minus times this. So this is equality cannot possible. Are you getting? Option 4 is also wrong option. Only option third is the right now option. I will see another type of example which had come CSR NET December 2019 exam. The question is, consider a linear transformation C from T which map from complex number to M2R. Notice here the linear transformation to different vector space with two different field. So this is linear transformation but not be operator. Are you getting? What is the difference between linear operator and linear transformation? Consider this is be a map given by T of z equal to T of x plus I, y equal to the matrix whose diagonal is xx and off diagonal y minus y. Then which of the following statement, here notice here not true, not here indicate which of the following statement is false. Option 1, T of z1 comma z2 equal to tz1 times tz2 where for all z1 z2 belongs to complex number. Option 2, T is singular if and only if z equal to 0. Option 3, there does not exist non-zero A belongs to M2R such that Tza is 0 for all z belongs to complex number. And option 4 indicate Tz1 plus z2 equal to Tz1 plus Tz2 for all z1, z2 belongs to complex number. Let's see the option. This is obviously very easy type question and very basic. At first, let's see the first option. Option 1, T of z1 comma z2 equal to Tz1 times Tz2 for all z1, z2 belongs to C. For this, at first calculate z1 times z2. This would be x1 x2 minus y1 y2 plus I times x1 y2 plus x2 y1. Notice the defined tz. Then tz1 would be, just notice at first, here along the diagonal the value is xx and up diagonal the value is y minus y. So obviously tz1 would be along the diagonal x1 x1 and up diagonal y1 minus y1, and tz2 would be similar type x2 x2 y2 minus y2. Then tz1 times z2 would be, notice z1, what is z1 z2? By this expression we can tell the linear transformation would be x1 x2 minus y1 y2 along the diagonal x1 x2 minus y1 y2, and along the up diagonal x1 y2 plus x2 y1, and here the minus times x1 y2 plus x2 y1. Okay, t of z1 times t of z2 would be this and this. Then this would be, this is equal to x1 times x2 minus y1 minus y2 minus x1 y2 plus minus x2 y1, here x1 y2 plus x2 y1, also here x1 x2 minus y2 y1 y2. Okay, and notice t of z1 z2 always similar to t of z1 times t of z2. That means option 1 is a right option. But here notice, here has indicate which option be false. Now let's see at first the fourth option. Because option 4 is similar to option 1, z1 plus z2 equal to x1 plus x2 plus I times y1 plus y2. Then t of this means the mapping here along the diagonal x1 plus x2, here also x1 plus x2, and along up diagonal here would be minus y1 plus y2, and here y1 plus y2. Okay, which is equal to, obviously just notice x1 x2 y1 minus y1 plus x2 x2 minus y2 y2, and this is actually t of z1 plus t of z2. That means t of z1 plus z2 equal to t of z1 plus t of z2. This proof has satisfied for all z1 z2 belongs to complex number. That means option 4 also be right. Then option 2 has indicate t is singular if and only if z equal to 0. A linear transformation always be singular when the determinant of associated matrix is 0. That means we have to prove this determinant of this matrix is equal to 0. Since this is the linear transformation. So determinant of this matrix equal to 0, that imply x square plus y square equal to 0, and x square plus y square equal to 0 means obviously x equal to 0 and y equal to 0. Since x equal to 0 and y equal to 0, so obviously since z equal to x plus iy, so obviously this means z equal to 0. Since x and y both equal to 0, means option 2 also be right option. If t is singular, if and only if z equal to 0. That means when z equal to 0, then obviously this linear transformation would be 0. Also, if t is singular, then that imply obviously z equal to 0. And third option indicate there does not exist non-zero a belongs to M2R such that trace of tza is 0 for all z belongs to C. Obviously this option is only right option because here given which of the statement is false. I have seen 1, 2 and 4 are right option. Since these are right options, then only false option is 3. Okay, let's check it. To check, trace of tza is 0 for all z belongs to complex number. And A be any 2 cross 2 arbitrary matrix over the real field equal to A, B, C, D. Consider this arbitrary matrix where A, B, C, D belongs to R. Then tza equal to, tz means this matrix times this matrix, then this tza would be x minus cy, other column minus ay plus cx, bx plus dy minus by plus dx. Now we have to check trace of tza equal to 0. And we all of us know trace means sum of diagonal. That means ax minus cy minus by plus dx equal to 0. And that imply a plus d times x plus minus c minus b equal to times y equal to 0. And this is equal to, this sum equal to 0 means a plus d equal to 0 and minus c minus b equal to 0. That imply a equal to minus d and c equal to b. Therefore, when a equal to minus d, that means since I have chosen A, B, C, D matrix, here A equal to minus D and for C equal to B, that means this would be minus A and this is B and this is also B. For this matrix, trace of tz times A obviously would be 0. Just check it on self. Okay, that means here has indicated there does not exist any non-zero A belongs to M2R such that trace of tza is 0 for all z belongs to C. This is wrong option. And since this is wrong option, that means this option only right option. Are you getting? Well, I will stop here. In my next video, I will introduce some more example of CSR net about this topic which I had discussed till now of linear algebra. But at first, I will again highly recommend you, if you don't see my previous video of linear algebra and vector space, please see at first this video. Then today's video would be so easy and also next video would be so easy. See you soon. Stay safe and stay positive always. and don't forget to do subscribe my channel for more videos. Thank you so much.